Recording in progress.
Hello, everyone. My name is Brittany, and I'm going to walk through with you how to do an ice table using the quadratic equation. Okay, so here's a problem. We're given the equilibrium constant K for the decomposition of PCl5 into PCl3 and Cl2, and that K constant is going to be that 0.0211. And we're asked, what are the equilibrium concentrations of PCl5, PCl3, and Cl2 in a mixture that initially is contained only by PCl5 at a concentration of 1 molarity. So those are going to be our two given things from this question. So straight off the bat, we know that we have to make an ice table. Given our Kc, we know that, but yet we don't know what those products and reactants are. So we're going to use our ice table to determine that. Okay, move this over. So I'm just going to write ice on the side. And as given in the problem, we have an initial concentration of that PCl5 to be 1. And then since the other concentrations were given for the products, we're just going to assume those are 0. Next, we're going to do our change in concentrations. So since we're only given reactants, we know that those are going to eventually get consumed through this reaction. So we're going to be decreasing that in terms of X. So minus X, whereas the products, we're going to be forming those since we start out with 0. So PCl3 is going to be a plus X and Cl2 is also going to be a plus X. Now, if there were coefficients in front of those products or reactants, say there was maybe a 2 in front of this Cl2, then we would just add a 2 in front of this X. Okay, moving on. Now we're going to fill in our equilibrium row. So we're just gonna take our initial and then also incorporate the change. So for our PCl5, we're going to have 1 minus that X value. And then for our PCl3 and Cl2, we're just going to have that X value. And we know our equilibrium concentrations in terms of X. So we're going to have to find X by using that Kc constant given to us in the problem. So we know that our Kc or our K equilibrium in terms of concentration is going to equal our products over our reactants. So that would be PCl3 over Cl2, well, times by Cl2, sorry, and then all over our reactant, which is the PCl5. Now, all three of these components in our equation are going to be represented in our K equilibrium because they are gases. Only gases and aqueous solutions are represented in these equations, not solids or liquids. You will not see those in your equations. Now, again, if we did have a coefficient, say again, like we mentioned earlier, I'll put it in red, say we had a 2 in front of our Cl2, that would, like we said, affect this change in X here to 2, make this a 2. And then we'd also see an exponent on that Cl2 concentration right here. So just make sure to look out for that. In this case, again, we don't have coefficients on any of our reactants or products. So there is just a 1, an invisible 1 there. Okay, so given our Kc, we can fill in that. We know it's 0.0211, and that's going to equal our concentrations, which we know in terms of X. So we know our PCl3 is X, and our Cl2 is represented by X. And those are going to be over that 1 minus X, which represents our PCl5. So now this is where we have an equation where we're trying to find what X is, because X will help us determine what those different x variables in our table represent, and that will give us our equilibrium concentrations for those different products and reactants that we're trying to find. So we're going to be using algebra from here to solve for our x value. So on the right side, I am just going to times 1 minus x to cancel out this denominator. And I'm also going to do the same on this side. 1 minus x multiplied by this 0.021. So 1 minus x and that's going to equal our x squared. Now to get rid of this 1 minus x, we have to make sure to distribute on this value and also taking into account that minus in the first portion. So if we will first do the 1, distributing over to the 0.0211, we just have 0.0211, and then we're also going to times the negative x times the 0.0211. So that will give us a minus 0.0211x, and that's going to equal our x squared. So we have that all distributive. Now we have to get all of those variables on one side, because in order to use the quadratic formula, which we're going to have to use, we have to have all our variables on one side and equal to 0. So just to keep this x squared positive, I'm going to move all the other variables from the left side over to the right side. So I'm going to have 0 equals my x squared. First, I'm going to move over the negative 0.0211x by adding it over to the other side. And then I'm going to subtract that 0.0211 value over. So this is the equation that we're going to be using for the quadratic formula. So if you remember our quadratic formula, we're going to have everything represented in terms of A, B, and C. So this imaginary coefficient in front of the x, that's going to be our A value. So our A is going to equal 1, and then this value in front of just the x. Oh, I realized I forgot to do squared there. And that the variable or the value with the x is going to be our B. And then this last number will represent our C that's not paired with any x. And we're going to make sure to include the negative. Okay, now we have our variables and we're going to use the quadratic formula. So we know in the quadratic formula, our x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac. That's going to be all over 2a. Okay, now let's just plug in our variables. So x is going to equal the opposite of b plus or minus the square root minus 4 times a, which is 1, and times c. And then that's all going to be over the 2a. So now let's shorten this and condense it a little bit. So if we'll just take this plus or minus. Under the square root, you should be getting, or let's just take that value and we'll square it. So you should be getting that whole, everything under the square root if you Take the square root of 0.0221 and then subtract those variables that are multiplying by each other and then square root it. You should be getting 0.291. And then again, we're going to keep that all over a value of 2. So with that, we can represent this equation in 2 ways. One of them is going to have the plus, one of them is going to have the minus. So I'm going to choose this one on the left, have the plus, and the one on the right is going to have the minus. Okay, so if you work out those values there, you should be getting for the plus to be 0.135. And then over here on the right, we're going to have negative 0.156 roughly. Okay, and so since those are our X values, we automatically know those are going to be our concentrations for PCl3 and Cl2. But which one's going to be the one that we choose? So automatically, we should know that this value here, this negative value on the right, is not possible because it is negative. We can't have a negative concentration of anything because that's just not possible. It's just saying I have -3 like cotton balls or something. It's just not possible. It's not a thing. So we know that can't be our concentration. So that does mean that this value on the left is going to be our true and real value for our X. So finishing it up, since we're finding our concentration of PCl5, PCl3, and Cl2, we automatically know from this value of X that our PCl3 and our Cl2 are going to equal that 0.135, and the units are still in molarity. Now, in order to get this last final concentration, we're just going to take 1 minus that 0.135, and then that should give us 1 minus 0.135, and that should give us a value of 0.865 units still in molarity. So this right here is going to be our answer. And that is how you are going to solve an ice table using the quadratic formula. I hope this helps.